This is lesson 4.8. So lesson 4.8, Bayes' theorem. Now guys, you'll remember in the past we've already discussed this formula here where it's conditional, where we're finding the probability of B after A has already occurred, right? And that was the probability of A and B over the probability of A. And that was the formula that we used. Well, Bayes' theorem, what happens is, guys, sometimes information is continual and you gain more information as time goes on. And so Bayes' theorem, what it does is it allows us to take new information and combine it with an old probability, something that we initially found. We can substitute in the new information. Okay, so it's used when new information is available after the initial findings and needs to be included into the new statistic. Now guys, these are sequential events, and so things keep happening. Information keeps being found. So it's a revision, or we revise the probability of the initial event. So that brings into what we think of as prior probability. The prior probability is your original probability that you originally knew. And then you have posterior probability, which is the revised version of that probability with the new information in it. Okay? Now, this is just an example, and this example will be done twice, one way and the second one a different way. So we're going to talk about this. But adult Americans are surveyed for credit card usage. Okay, so several adult Americans are surveyed. It says use subjective probability to estimate the following. The first thing we're going to estimate is the probability that the subject is a male. Alright, so we're using subjective probability, which means we're using our own thoughts and whatever. So your information might be different than mine, so I'm just going to use what the book gives us. In case you don't know, this isn't necessarily found in the book. It's on the CD that comes with your book. If you put that CD in your computer, look for 4.8 Bayes' theorem. You'll find this information, okay? I don't know why they did it that way, but that's what they've done. Now, let's just say that you think that, well, 50% of the population are male, so you have a 50% chance of that, right? So you're going to say your probability of it being a male is 0.5. Sound good? Then, after some time, the second part here is after selecting the subject, we learn that this person smokes. So we want to find the probability of it being a man again, okay? Knowing now that this person smokes. So in our knowledge, we know that there's more male smokers than female smokers. So we know this increases the odds, right? And so our revised probability that we're going to assume is that this now becomes 0.85. You have an 85% chance now that what you get is a male. So that's just what we think, okay? Alright, so that's subjective, and that's subjective thinking. Which one of these is the prior probability? The 0.5 would be the prior probability. That's what you did before you had the new information. The second one would be our posterior probability, and so that's what we got after we got new information, okay? That's what we solved for. Since it was subjective, that's what we calculated it to be in our heads, okay? All right. Now, that's not how Bayes' theorem works. That's just to explain prior probability and posterior probability, okay? Now, here's the example, okay? Let me explain to you Bayes' theorem, the formula. This is the probability of A knowing B happened, okay? It's the probability of A times the probability of B knowing A occurred. All divided by, now this should be all underneath here, guys, but I didn't have room, so I put a plus here and then I put the additional information. But it's going to be the probability of A times the probability of B because of A, so it's identical to what's on top there. But it's plus the probability of the complement of A times the probability of B because of the complement of A. Okay? And I know that's not going to make a lot of sense right now, so I'm going to give you an example problem. Hopefully it'll help us understand it a little bit better, but that's the formula. Now I'm going to have to erase that formula because I need room on that board, but you guys have it, so if you have it written down, you can use it to see what's going on here, okay? Now, here's our example of how Bayes' formula works. All right, in Orange County, 51% of the adults are male. I'm pretty sure you can figure out by now that that means that 49% are females, right? I'm not going to write that down yet. Just know 49% would be females. One adult is randomly selected. Okay. Now, we are actually going to have to find the probability of it being a male. The probability of this being a male is 0.51. Okay? I moved the decimal twice to the left on 51%. That gives me 0.51. All right. Now, it was later found that the subject smoked a cigar. Well, 9.5% of males smoke, and 1.7% of females smoke. Now the reason why we want to know the females, guys, is because they're our complement, right? Males plus females is 100%. So we need to know the complement. This information is given to us, so I'm not like pulling this out of air. This is given to you in the book or in the question, and so you guys will have that given to you as well, okay? So, all the information you'll need will be given to you. So here we go. Let's identify all the different parts here so we can come up with our new probability. Our original probability, our prior probability is just 0.51. That's what the probability is. But with the new information, knowing that the new person is a smoker, and we want to know the probability of it being a male, we need to put some things together here. Let's first think of the probability of its complement, which would be a female. That would be 0.49, because 49% of all the other adults in that county would be females. Then we want the probability of the cigar, because we know the probability of males, or because of males, that probability is this decimal moved twice to the left, 0.095. And we also need to know the probability of a cigar with our complement, which would be females. Our females, move the decimal twice to the left, is 0.017. Okay? This is all the information we need to be able to plug it into Bayes' theorem now. Okay? I found the original probability, its complement. I found the new information's probability here basically for males, the new information's probability because of females, and now we can plug this into Bayes' theorem. I'm going to have to erase this though because I need the space. You hopefully have written this down so you can keep track of what we're doing. Now, here we go, plugging it into the formula. The way this formula is going to work is we want to know the probability of males because we know one of them is a cigar smoker. So the original probability of a male times the probability of the cigar because it's a male all over the probability of a male times the probability of cigar because of a male plus the probability of a female, which is the complement, times the probability of a cigar because of the female. Okay, we know these numbers now, we just barely found them, so we're just going to plug them in. 0.51 is my PM, right? Times 0.095. Oh, forgot the zero. Let me rewrite it. 0.095. That's the probability of the person being a cigar smoker because they're male, all over, this is the exact same numbers here, so 0.51 times 0.095 plus, now this is the probability of it being a female, right? We know that probability was 0.49 times the probability of them being a cigar smoker because they are female is 0.017. Now guys, I know that you just want to cancel these two out because they're identical, but this plus does not allow you to cancel those out. If this were a multiplication, then you could. But because of this plus, these have to be solved and then divided into this answer. Now guys, the way you would solve this, you'd do 0.51 times 0.095 and you'd write that answer over here. And down here you would have that same answer, and plus, you'd multiply these two, 0.49 times 0.017, and then you'd add those answers and you'd put that on the bottom. And when you divide those, you would get, rounded to 3 decimal places, 8.853. You would have a 0.853 chance of it being a male. And that's how Bayes' theorem works. Now we estimated 85% because the book cheats, but that's how Bayes' theorem essentially works. Hopefully that makes a little bit of sense, and it takes a little bit of practice to get used to that.